bounces off the inner core and is expelled, and that's what we call a supernova explosion. The outer layers are thrown off with speeds typically some 10,000 kilometers per second. Our sun will not become a neutron star, but it will become a white dwarf. We talked about the Crab Nebula last time, and the Crab Nebula is a remnant of a supernova explosion which occurred, believe it or not, on the 4th of July in the year 1054, talking about fireworks. This supernova explosion was noticed by Chinese astronomers. They called this a guest star. Chinese astronomers were very prestigious. The reason for that was that these Chinese astronomers advised the emperor. They looked at the sky and they derived from the sky information that was key for the emperor. They knew how to interpret the occurrence of comets, or for instance, shooting stars, or a particular lineup of planets, and certainly the appearance of a guest star. And they would know that, for instance, a comet in a certain part of the sky might mean that there would be hunger, or there would be diseases, there would be famine, or it would be a good time for a battle, or it would be a bad time for a battle. And that's what these people were doing. They were advising the emperor, and therefore they were keeping a very close eye on the sky. No pun implied. This star was visible for weeks during the day when it exploded, and it was the brightest star in the sky for years to come. It is a complete puzzle why there isn't a single report by any European astronomer on the occurrence of the supernova of 1054. It is very puzzling. Now, you can argue that in the Netherlands and in England there are always clouds, it's always raining, so you can't see the sky. Okay, I grant you that. But then we have Italy, and we have Spain, and we have France. And it is very strange. It must have been a cultural thing somehow. In the 11th century, somehow, Europe was not interested in looking at the sky. This is something they could not have missed. But they didn't write it down. I now want to pursue the spin-up of this star when it collapses from 700,000 kilometers to 10 kilometers. If we round the numbers off a little bit, then the reduction in radius is about 100,000. It's really only 70,000, but let's just make that 100,000, 10 to the fifth. That means r squared goes down by a factor 10 billion. And if r squared goes down by a factor 10 billion, then the moment of inertia goes down by a factor of 10 billion. And so omega must go up by a factor of 10 billion. If you started off with a star that rotated about its own axis in 100 days, it ends up rotating around in 1 millisecond when it has become a neutron star. A neutron star, 10 kilometers. It has about the same mass of the sun, a little more. And it spins around in 1 millisecond. At the equator of the neutron star, you reach about 20% of the speed of light. We know of hundreds of neutron stars in the sky. 2 of them have, in fact, rotational periods of 1.5 milliseconds. Many of them much slower, and we discussed last time why that is. Because remember, in the case of the Crab pulsar, the pulsars slow down. Nature is tapping on the rotational kinetic energy of these pulsars and is converting it into other forms of energy. In the case of the Crab pulsar, radio emission, optical emission, gamma rays, X-rays, and even jets. The Crab pulsar was slowing down every day 36.4 nanoseconds, which led to a staggering power output. I still remember the number, I think 6 times 10 to the 31 watts. In 75 years, the pulsar slows down by 1 millisecond. So the 33 milliseconds would become 34 milliseconds in 75 years. If the star has an original, there's no star, it was a disk, right? If the star has an original magnetic field, which most stars do, oh, I lost my star, but that's okay. Then in the collapse, the magnetic field will become stronger. And this is something you will learn about in 802, why it becomes stronger. So most of these neutron stars have strong magnetic fields, and most rotate very fast. And for reasons that we don't quite understand, many of them blink at us. They blink at us in radio emission. We believe that there are two beams of radio emission, like a lighthouse, going out from the two magnetic poles of the neutron star. And as the neutron star rotates, and you are on Earth, if it sweeps over you, you see radio emission, you see nothing, see radio emission, you see radio emission. So many pulsars whose beam doesn't sweep over the Earth, we would never be able to see, of course. And in the case of the pulsar and the Crab, it's even more special because that pulsar also blinks at us in the optical, in the X-rays, and in the gamma rays. And so now I would like to show you some slides and discuss in a little bit more detail the supernova explosions and the fabulous light output and the spin-up. So I have to make it quite dark. Make it completely dark. There we go. A cave drawing made by Navajo Indians, and some people have speculated to what extent the Navajo Indians may have seen the supernova in 1054. It's unclear, but it is a possibility. The moon certainly gets very close to the supernova, but it also gets very close to Venus, and so this is something that is not well established, but it is a possibility. Here you see a galaxy in which a supernova occurred, and when the supernova occurs at its brightest, it can be brighter than all 100 billion stars in the galaxy. That's how much energy is released in optical light. You see that it is at least as bright as the entire galaxy. From this picture to this picture is about 1 year. This occurred in 1972. And over the period of 1 year, you can still see this star quite clearly, but it has diminished in strength quite a bit. And then a great thing happened in February 1987. On the 23rd of February, a supernova went off in the Large Magellanic Clouds, which is a satellite galaxy to our own galaxy. It's a distance of about 150,000 light years. And there was an astronomer who was observing in South America. His name is Ian Sheldon. And he left the dome to look at the stars, and he decided that to take a pee outside. And as he was taking a pee, these were his own words, he looked at the Large Magellanic Clouds, and he said, "Hey, that is funny. That star is not supposed to be there." And he was the discoverer of what is now known as 1987A. An enormous supernova going off so close to where we live. And the next slide shows you the same portion of the Large Magellanic Clouds, and you can clearly see that there is a very bright star. He could see this with his naked eye. This is a picture made by the Hubble Space Telescope of supernova 1987A. The inner ring that you see is the result of matter that was thrown off by the star before it went into supernova explosion. Some 25,000 years earlier, it expelled gas in its equator. This is really a circle, although it looks like an ellipse because of the projection effect. And this ring of matter moved out with a speed of about 8 kilometers per second. And it has a radius of about 8 light months. And so 8 months after the supernova explosion, the ultraviolet light and the X-rays from the supernova caught up with this ring of matter, and they excited it, and it became visible. Before the supernova explosion, this ring was not visible. We are expecting in a few years that the matter itself that was thrown off with a much more modest speed of about 10,000 kilometers per second, that matter will also plow into this ring, and then we expect some real fireworks again. There is no explanation that people agree upon for these two called hourglass rings. They are quite mysterious, and there are papers written on it, and people disagree on their origin. Supernovae explosions in our galaxy and in the Large Magellanic Clouds are quite rare. We expect no more than about 1 in 100 years. The previous one that could be seen with naked eye was in the year 1604. It's called Kepler's supernova. And 1987A was really the first that could be studied with modern equipment, radio observatories, X-ray observatories in orbit around the Earth. With some luck, you may see a supernova explosion naked eye in your life. The chance is no better than 10%. So maybe it will help if occasionally you take a pee outside and you become as famous as Ian Sheldon did, who is now a very famous man. See you Monday.